In this section of Unit 4, we are going to graph rational functions, and they're a lot like reciprocal functions with a couple extra little pieces, things that are new. So we're going to still deal with vertical and horizontal asymptotes just like we did last time, domain and range just like we did last time, but we have something new which is called point discontinuities. So we're going to find those and see how those work with our information. So as we move into some information, starting with rational functions. What are they? Well, they're they're functions where you have variables in the numerator and the denominator. So remember, with reciprocal, we only had them in the denominator, but now we have them in both. We have this new term called point discontinuity. And that's just any common factors that you have in your numerator and denominator. And what it does is it means that there will be a hole in the graph instead of having a vertical asymptote at that point. So for an example like this common factor right here, because it's a common factor in the top and bottom, so the common factor is x plus 1. And so what we do is we take that and we set it equal to 0 to get x equals -1. So at x equals -1, we'll have a hole in the graph. So this graph will actually look like a line, but then once you hit -1 at x, it'll keep going like this, but it'll just have this hole in it. And that right there is the point discontinuity. So horizontal asymptotes, we have 3 different scenarios for how to find horizontal asymptotes. If your higher degree is in the top, you don't have a horizontal asymptote. If your higher degree is in the bottom, your horizontal asymptote is y equals 0. And if you have equal degrees, then you do the leading coefficient over the leading coefficient. But how your vertical asymptotes, those still stay the same, where you set your denominator equal to 0. So the first thing you want to do is you start by factoring the problem as much as you can. Find your zeros, and I should even add that after you factor it, you should simplify. So factor and then simplify as much as possible. I need to kind of rewrite that. There we go. Find your zeros, which is setting your numerator equal to 0 and solving. Find your asymptotes, so vertical and horizontal, so VA and HA. Any common factors? If there are, then instead of having a vertical asymptote, it'll be a point discontinuity, which remember is just a hole in your graph. Then we'll do domain and range, and then we'll actually graph the function. So look at our very first example here, and let me go ahead and shift these over. I bet they're all going to be kind of off a little. Let me just fix those. Okay, so here's our first example. Numerator has x and denominator has x, and that's what makes this a rational function. So the first thing is to factor. Well, in this case, everything is already as simple as it's going to get, so there's nothing to factor. So I'll just write nothing to factor. So factor is done. All right, so then in your next spot, what we have then is zeros. So zeros is taking your numerator, which is x, and setting it equal to 0. And there's nothing to solve there. It's done, so it's the point 0, 0. And so I'm going to go ahead and just graph 0, 0 on that coordinate plane now. All right, asymptotes. Our degree of our numerator is 1, and the degree of the denominator is also 1, right? So that one is 1. So since we have equal degrees, what that means for our horizontal asymptote is that it will be y equals, and you look at your leading coefficients. In this case, it's 1 over 1, so it's y equals 1 as your horizontal asymptote. So I'm going to go ahead and just put that horizontal asymptote right there at y equals 1. Then to get your vertical asymptote, you take your denominator and set it equal to 0, so x plus 2 equals 0, which means that your vertical asymptote is at x equals -2. All right, common factors, we don't have any, so we don't have any point discontinuities. Oh, and we should probably put our vertical in here at x equals -2. There we go. Then we want our domain and range. Well, if we're working with domain first, we have x such that x, and remember we're looking at our vertical asymptote, it does not equal a -2. Or if we put it into our interval notation, negative infinity to negative 2, use parentheses on everything, and then negative 2 to a positive infinity. If we are going on to our range now, that's working with our horizontal asymptote. So I'm going to start with the fact that this problem was an f of x problem. So f of x such that f of x does not equal a positive 1, or negative infinity to 1, union 1 to infinity. Okay. Now what we need to do is graph this thing, and it's still going to look like a hyperbola. And since this is our x-intercept here, we're going to go ahead and draw part of our hyperbola here, and then just reflect that over, oops, shouldn't cross, reflect it onto the other side here. So there's the two pieces to your graph. And you'll notice that this has that negative slant to it, so it's a little bit different when you still have an x in your numerator. So just be careful that you're not using the same reciprocal information because there's an x up top. Okay, so here's another example. Start with factoring. Well, the top, there's nothing we can do to it, so it's still x minus 1. But the bottom can be factored into x minus 3 times x minus 1. So then what happens is we have a common factor, so those are going to cancel out, leaving you with 1 over x minus 3. And so now this is just a reciprocal function because it doesn't have a variable in the top anymore. So when we go to graph it, we're going to use properties of the reciprocal function. So zeros would be taking your x-intercept, or I'm sorry, your numerator and setting it equal to 0. Well, that's not a thing. You can't do that. There's no x. So there won't be any zeros. Asymptotes. So we have this degree up here is 1. The degree down here is 2. So we have low degree over high degree. And so since we have low over high, what that's going to mean for our horizontal asymptote is that it is y equals 0. So I'm going to go ahead and put our line, or our dotted line, to represent our horizontal asymptote. Then we need our vertical, which is taking your denominator and setting it equal to 0. So x minus 3 equals 0, which means your vertical asymptote is at x equals 3. And so throw your vertical asymptote here at x equals 3. All right, now did we have a common factor? We did. We crossed out x minus 1. So what that means then is that we're going to have a point discontinuity. So point discontinuity. That should not look like that. At, and now you get it from setting this equal to 0. So at x equals a positive 1. So on your graph at a positive 1, there's going to be a hole. Okay, so there's that. And then domain and range. So let's just graph this thing first so we can kind of see how this domain and range is going to play out. So because this is a reciprocal function and this is a positive numerator, that means our top part of our graph is going to go here and then reflect it onto this side. However, when it hits a positive 1, there's a hole in the graph. And then we continue our graph on that way. So here's what happens. We need to get our domain, which is not so bad because we know that our domain can't be 3 and it also can't be a positive 1. So domain would be x such that x does not equal 1 and x does not equal 3. So now when you go to put that into your interval notation, you have negative infinity to 1, union 1 to 3, union 3 to infinity. Then when you go to throw it into your range, this one is a g of x problem, such that g of x does not equal 0, because that's this horizontal asymptote here, and g of x does not equal a negative 0.5. And I get this number by plugging in a number close to positive x value, or positive x equals 1. So I would do like x equals 1.01. And that's how I get that number. And then when we go to throw that into interval notation, we do negative infinity to negative 0.5, because that number comes first, union negative 0.5 to 0, union 0 to a positive infinity. All right, so one more example. In this example, same thing, factor first. So we end up with x plus 4, sorry, that's a 4, times x minus 3 over x minus 3. Those are common factors, leaving you with x plus 4 over 1, which is just x plus 4. And so when we graph this, is actually going to be a linear graph. It's going to be a line. So to get your 0, take your numerator and set it equal to 0, which would then give you x equals negative 4, or the coordinate point negative 4, 0. So we can go ahead and plot that right here, negative 4, 0. Asymptotes, we have high degree over low degree. And what that means then is that we have no horizontal asymptote at all. So remember, the degree of this one, the degree is 2. And down here, the degree is 1. All right, common factors, we did have one, and it was x minus 3 was our common factor. And so that would mean then we're going to have a point discontinuity at x equals a positive 3. And so that would be when you're setting that equal to 0 and solving. So when we go to how to graph this thing, the slope is a positive 1, so we're going up 1 and over 1, right? So here, up 1 over 1 here, up 1 over 1 here, and I'm going to go until I hit x equals 3, because we need to know where that hole is going to be. So up 1 over 1 here, and then there we go, there's our hole. So now I can connect this and make the line this way, and then also this way, with our hole. So when we go to do our domain, the only x value that isn't going to work is 3. So we'll write our domain as x such that x does not equal 3, or negative infinity to 3, union 3 to infinity. And then our range, so this one is, I think, h of x, is that what I used? Yep, so h of x such that h of x does not equal what number? And so if you look over, it hits at 7. So h of x does not equal 7. Or in your interval notation, negative infinity to 7, union 7 to infinity. And there are your graphs. So those are the 3 different types that you're going to see in this one. There's a couple other ones that look a little bit weird, but we'll do those in class together. So just make sure that you memorize, how do you know where your vertical asymptotes are, or horizontal asymptotes. And then I forgot, even with your vertical, setting your denominator equal to 0, that's not a thing either. 1 equals 0, so there's no vertical asymptote as well.